I am going to solve problems 1, 2, and 3 on the half-life worksheet. It's file number 4 in the nuclear folder. So if you want to go grab a copy of this, go for it. So I'm not going to do 4 and 5 because 4 and 5 are basically repeats of a couple of these up here. So I'm going to do these, and I'm not sure if I'm going to use the table or the graph or maybe both, but I'm going to get started right now. So let's look at what we got here. And this one says sodium 24. A lot of kids see a number and they think that that's important. Well, it's nice to know that it's sodium 24, but that's just telling us what isotope it is. So really the name of this isotope doesn't matter. So like phosphorus 32, I mean, if you're worried about the number, you can get rid of these isotope numbers and you won't have to think about them. So anyway, back to number 1. The half-life is 15 hours. So if we were looking at the table here, and if we started time at 0 and half-lives at 0, so after 1, 2, 3, 4, whatever half-lives, however many we need to solve the problem, the time it would be counted out by 15s because 1 half-life is 15 hours, 2 half-lives would be 30 hours, and then 45, and then 60, and 75, and so on. So the half-life is 15 hours, and I mean, I guess I could fill in the fraction thing too. At a time of 0, it's still just 1, or you could say 1 over 1. And after 1 half-life, it's down to 1/2, and then half of a half is a fourth, half of a fourth is an eighth, and a 16th, and a 32nd, and so on. But it says, how much will remain in an 18-gram sample after 60 hours? So 60 hours, that is right here, and we want to know the amount left. So we want to know what goes in that box. So how much did we start off with? We started off with an 18-gram sample. So we started off with 18 grams. After 1 half-life, we'd be down to 9 grams. Half of 9, if we cut that in half, another half-life, that would be 4.5. And then after the 3rd half-life, that would be 2 1/4. And then after another half-life, we would be down to 1 1/8. And so there is our answer. If I was going to use the graph to solve this, what would I do? Let's see here. The half-life is 15 hours. So instead of marking this out like this, I'd go, so here's 15, here's 30, here's 45, here's 60, here's 75. I could keep going, but I don't need to. And instead of this scale that's here, I probably would rather I'd rather have my 18 grams at the top. So that was my original amount. And then if we were going to count this out, half of 18 is 9, and 4 1/2, and then half of that would be 2 1/4, and then here is 1 1/8. It's kind of hard to do this now that I already know the answer. It's like I'm leading myself to it. But anyway, if I was using the graph then, 60 hours, we know that 60 hours is right here. So all we do is we just go down. There's 1 half-life, and we're down to 9 grams. 2 half-lives, we're down to 4.5. 3 half-lives, we're down to 2.25. And then 4 half-lives, we're down to 1 1/4. So we get that same answer either way. Honestly, my opinion, I think I prefer to use the table. That just seems to be how my mind works for these problems. Okay, so let's look at number 2 here. It says, after 42 days, a 2-gram sample has gotten whittled down to 1/4 of a gram. So since they give us this amount and this amount, let's fill in the real amount column first. And so our starting amount was 2 grams. Oh, not 20, just 2 grams. If we cut that in half, that's 1. If we cut that in half, that's half. If we cut that in half, that's 0.25. And we can stop right there because that's what this problem mentions. And maybe you've noticed you can leave these 2 columns the same for every half-life problem because those are always going to be the same. But anyway, let's see here. After 42 days, 0.25 grams is left. So basically this problem is telling us that right here at 0.25 grams, that was 42 days. Okay? So now we're thinking about using some division because if we started at a time of 0 and we've got some number here and some number here, and then we've got 42. So we've got 1, 2, 3 numbers to get us to 42. How do we figure out what these other numbers are here? Well, we just go 42 divided by 3, and that is 14. So we're going to count by 14s. 14, 28, 42. I guess I've kind of forgotten what the question was. Oh, okay. The question was, what is the half-life? And so the half-life is right here, the time it takes for it to get cut in half. So after 14 days, we went from 1 down to 1/2. So the half-life is 14 days. If I were going to use the graph to solve this, we started off with 2 grams. So our total amount, our first amount is 2 grams. And we're going to cut it in half until we get down to 0.25. So half of 2 is 1. Let's get rid of the 75 here. Half of 1 is 0.5, and then half of 0.5 is 0.25. So how many times, or what gets us to right here? What gets us to this point? This was the 42 days, right? 42 days went by, so this is 42 days right here. So 0, 1, 2, 3 divisions. So we've got 1, 2, 3 chunks of line to get to 42. Well, 42 divided by 3 is 14, so this graph must be counted out by 14s. So 14, 28, 42. The question says, how long is one half-life? So one half-life was 14 days. So if you think in the graphical way, then this might have helped you. I don't know what works for you. And then let's look at number 3. Number 3 says polonium 230 or whatever it was has a half-life of 164 seconds. So that means if we start off at a time of 0, every time we go by a half-life, it's 164 seconds. So all we have to do is just keep adding 164 to these numbers. So I'll do that. I'll be right back. Okay, so what I did here was I just took and I added 164 1, 2, 3, 4 times here to just keep adding that up. And let's go back to the problem here, and it says 164 seconds. How many seconds would it take for 8 grams? So our starting amount is 8 grams. So I'm going to put an 8 right here. And we're going to get whittled down to 0.25 grams. So if we cut 8 in half once, we're down to 4. If we cut 8 in half twice, we're down to 2. If we cut it in half a third time, we're down to 1. If we cut it in half a fourth time, we're down to 0.5. If we cut it in half a fifth time, that's 0.25. And that's how much time we had in the problem. So how many seconds was that? To get to the 0.25, that was 820 seconds worth. Okay, so our answer there is 820 seconds. So if you wanted to use the graph to solve this problem here, our original amount was 8, so that would be up here. Cut that in half 4, cut that in half 2, cut that in half 1, that's right here. Cut that in half 0.5, that would be right here. And then cut that in half, that's 0.25, that would be right here. So we're interested in this 5th half-life right here. And what else were we given? We were given that the half-life is 164 seconds. So one half-life is 164 seconds. 2 half-lives was 328. 3 half-lives was 492. I'm just cheating, I'm looking up there. And 4 half-lives was 656. And then 5 half-lives was 820 seconds. So 820 seconds is what we got. And there is a 9-minute video on solving 3 half-life problems.